This is a first of a couple of recordings I'm going to try to do for you guys. I'm going to try to keep them as short as I possibly can, but I just want to highlight some of the anatomy that you're learning and kind of put it all together in one place so that hopefully you can kind of see how this is going to come together as a whole. So you memorize the circulation, the blood flow. That's very, very important. The other thing that we were talking about is the electroconductivity of the heart. We looked at the myocardium and the 4 properties that it has that makes it very good for conducting electrical signals. And so I'm going to just kind of walk you through the pathway of how that happens in the heart. So a couple things that I want to point out before we get started here is to depolarize is just a way of saying to contract. To repolarize is to relax. When you guys are looking at an EKG, we're just talking about a very simplified EKG. So you have your P wave, your QRS complex, and bear with my art here, and then you have a T wave back here. So this is your P, Q, R, S, and then this little T wave here. And all you guys have to know about that is that your P wave is your atrial depolarization, which just means that the atrial, both the atrium are contracting. So your P wave is atrial depolarization or atrial contraction. You have your QRS complex, which is ventricular depolarization or ventricular contraction. And then you have your T wave, which is your ventricular repolarization. So how this comes into play, if I was going to ask you a question, is if I said there's an irregularity in the P wave, what does that mean? You should be able to tell me that that's going to be a problem with atrial contraction. And then you should be able to make inferences on how that's going to affect your stroke volume. If I said that there's an irregularity in the QRS complex, you should be able to tell me that that's an irregularity in ventricular depolarization or ventricular contraction, and you should be able to understand how that could potentially affect the stroke volume. And then over here you have your T wave, which is your ventricular repolarization, where it relaxes, and if there's an irregularity there and what that could potentially do to the cardiac cycle. So I'm going to kind of talk you through this whole process here, and then like I said, I'll try to keep these short and come up with another one here. So just for the electroconductivity, we're going to label this. This is your right atrium. These are your AV valves here. Okay, so on this side, this is your tricuspid. I'm just going to abbreviate just so it doesn't get too sloppy. Down here, you have your right ventricle. Over here, you have your left atrium. You have your left ventricle. This is your mitral valve right here. It's a little bit hidden, but that's that mitral valve right there. This is your aortic valve. These are your semilunar valves, just so you know you have 2. This would be your pulmonary one kind of tucked back here. So just to kind of get your bearings on what's going on here. So if you can imagine the heart starting off in diastole, right? Because I'm about to talk you through what happens when it goes into the contraction portion. So before you have the electrical signal that fires, your heart is in its relaxed state. So you have deoxygenated blood coming back from the body through the superior vena cava and then through the inferior vena cava. That is filling your heart on the right side with deoxygenated blood. At the same time, you have blood coming back through your pulmonary veins, filling your left atrium with oxygenated blood. That's coming from your lungs, right? And this is the heart in its relaxed state and it's filling. So your AV valves are wide open. And when you think about the reason that these valves are going to be open is this is the filling stage of your heart. So you have all this blood coming in through your right atrium, through your left atrium, and essentially filling your ventricles as well. So when you start initiating this heartbeat, what happens is your SA node right here, located in your right atrium, it fires. And this is essentially your P wave. This is also known as like the pacemaker of the heart. So your SA node is going to fire. And what it does is it causes atrial depolarization. So this is me showing you that your atria are now contracting. And when you think about contracting down, what it's going to do is it's going to force any blood volume that's still up here in the right atrium or in the left atrium down into the ventricles, right? So that's why it's contracting down. At the same time that this is happening, it's going to fire here. This is your AV node. Your AV node is going to send a signal to your bundle of His. Now this is kind of the important transfer here because the bundle of His is going to slam those AV valves shut. All right, so right now they're open. You're about to go into systole, you're about to contract. So these AV valves are going to get slammed shut by the bundle of His. That is your lub. The first heart sound is that lub. So now your AV valves are shut. Okay, there's nothing getting through them anymore. So you have a certain amount of blood volume hanging out in your ventricles, and this is your end diastolic volume. A certain amount of blood is in there from the filling stage. So these AV valves have been slammed shut, and now you're going to start ventricular depolarization. You're entering this QRS complex, and that happens because you get a signal that goes down your left bundle branch and a signal that goes down your right bundle branch and then up these Purkinje fibers, and that's going to start to contract down your ventricles. And when it contracts down, it's really going to increase that pressure because you have blood volume that's hanging out in here, and now you're scrunching down on it. And what that's going to do is start to push open those semilunar valves. Okay, so that pressure is going to force those semilunar valves open, and both of your semilunar valves are basically the gateways to your arteries. So you have your, I'm going to write it over here because it's getting a little slappy there, your pulmonary semilunar valve, and that is on the right side. And then you have your aortic semilunar valve, and that is on the left side. This one goes into the lungs. This one goes into the body, okay? And so you have your ventricles contracting, and they're going to eject blood through your pulmonary semilunar valve and at the same time eject blood through your aortic semilunar valve. And the volume of blood that they eject is considered your stroke volume. So here's a stroke volume, and here's a stroke volume, okay? So that is what we're talking about when we're talking about stroke volume being ejected out. And we can talk about the preload contractility and afterload on another diagram. But this is kind of the electroconductivity pathway. After your ventricles are done with their depolarization, after they're done contracting, they go into this T wave, which is where they repolarize or relax. When your ventricles relax, your semilunar valves shut and your AV valves open. So when your semilunar valves shut, that's that second heart sound, or your dub. Your AV valves and semilunar valves are never open at the same time. And when you think about when one is open versus when another one is, it makes sense for the cardiac cycle. So when your ventricles repolarize, they relax, your heart goes back into that diastole or that filling stage. So that's where you're going to get that blood volume back in, and then you're going to start this process all over again. So I hope that helped. Like I said, we'll talk about this in lecture 2, and I'll try to do a couple different series of these. But that's kind of the electrical cycle for you guys.